This is the video for section 4.2 notes, slides 9 and 10. All right, in section 4.2, we're talking about something called the mean value theorem. All right, so the mean value theorem says if y equals f of x is continuous at every point on the closed interval a to b and differentiable at every point of its interior a to b, then there is at least one point c in a to b at which f prime of c equals f of b minus f of a over b minus a. All right, so that's what it says. But what does it mean? All right, so first of all, okay, if a function is continuous on the interval a to b, what does that mean? That means if we have a graph, we start with an a and with a b, and we have an endpoint at a and an endpoint at b, and we go from a to b without a hole, asymptote, a jump, anything like that, right? So remember, it has to be continuous. So in other words, to make matters very simple, we have to draw without picking up our pen, right? So something like that maybe, or something like that. Or, well, if I do this, I didn't pick up my pen, correct? So that is still continuous. However, now we go to the next part. It says every point on the closed interval a to b and differentiable at every point of its interior a to b. So what does that mean? Well, now that means from endpoint to endpoint, I cannot have a corner point. So like this last drawing here, that has a corner point. So that is not allowed. I cannot have a cusp. So I couldn't have something like that, right? Which looks very similar to a corner point anyway. I couldn't have a vertical tangent, so I couldn't go like that because the derivative is undefined at that location, right? And so, okay, I can't have any of those. All right, and so the basic picture that I like to draw is something like that. All right, and so it is a continuous graph, and there is no lack of differentiability, meaning no corner point, cusp, vertical tangent, something like that. All right. Now, okay, what I like to say is you must draw without picking up your pen, and it must be smooth, right? But then also it can't have a vertical tangent. All right, so let's start with that picture. So go ahead and draw that. All right, and it says then there is at least one point in C. Okay, sorry, one point C in A to B. So that means C is somewhere between A and B, at which f prime of C equals f of B minus f of A over B minus A. Well, what do f of B and f of A mean? Well, f of A is this y value. F of B is this y value. All right, so what does f of b minus f of a over b minus a? Well, that's actually just slope, right? It's like y2 minus y1 over x2 minus x1. Isn't that really all that is? And so, really, f of b minus f of a over b minus a is the slope of the secant line. All right, so write yourself a note. That is the slope of the secant line. Or in other words, it is just the slope of the line connecting the points at A and B. All right, so that's what the right side of the equation means. All right, well, what about the left side? Well, the left side is f prime of C. Well, what is f prime of C? That is the slope of the tangent line to f at x equals c. So c is some interior point where what we're saying is the slope of the tangent line is equal to the slope of the secant line. In other words, these two lines, the tangent line and the secant line, are parallel. So that's what the mean value theorem says. If the function is continuous and differentiable upon this interval, then there will be at least one tangent line that has the same slope as the secant line. All right, so let's draw like an example. All right, so once again, endpoint, endpoint. All right, and so let's say I draw like this. Okay, so let's make a note of the secant slope. Is there at least one point where the tangent slope is equal? Well, yeah, right about here, tangent slope, same, parallel. And then actually here, this one would have a tangent slope as well. So this one would have two, right? So what we're saying is there is at least one, okay? Now, let's take one of those other cases that we talked about, okay? What if it wasn't differentiable? All right, so let's say I start here, and now it's not differentiable, okay? So make a note of the secant line, right? Is there a place where the tangent line is parallel? Well, the answer is no, because this is linear, right? So the tangent line would be like that, and tangent line would be like that. So this is where that is not true, right? But remember, the mean value theorem says if it is continuous and differentiable, then there is at least one c, right? Where the derivative or the slope of the tangent is equal to the slope of the secant. So this basically, well, mean value theorem does not apply there because it's not differentiable. Okay, and it wouldn't apply if it was continuous either. All right, so that is understanding the mean value theorem. Now, mean value theorem is super important. The AP test will specifically refer to the mean value theorem, so you do have to have it memorized. All right, so let's see another problem involving the mean value theorem. All right, so it says determine if f satisfies the conditions of the mean value theorem. If so, find all possible values of c. All right, so f of x equals x cubed minus 3x plus 5 on the interval negative 3 to 2. All right, so first of all, does f satisfy the conditions of the mean value theorem? So first question, is the function continuous on negative 3 to 2? So in other words, is there any sort of discontinuity, right? Is there a hole, a jump, an asymptote, or some sort of an oscillating spot? But that's really not that common. All right, so is there a hole, right? Meaning, is this function x cubed minus 3x plus 5 ever undefined from negative 3 to 2? Well, the answer is no, right? Because the domain of x cubed minus 3x plus 5 is all real numbers, right? So there's no asymptote, no hole, no jump, anything like that. So it is continuous. All right, so now is it differentiable? All right, so how do we determine that? Well, we consider the derivative. All right, so what is f prime of x? All right, so f prime of x, 3x squared minus 3. Is that differentiable, or does that function exist on the interval negative 3 to 2? Remember, we don't include the endpoints because a function is not differentiable at its endpoints. All right, but is 3x squared minus 3 defined for all values between negative 3 and 2? Of course, right? Because it's quadratic. That never has any jumps, asymptotes, or holes, or anything like that. And so we can say, yes, it is differentiable. Therefore, the mean value theorem applies. All right, so what does the mean value theorem say? It says f prime of c, so 3c squared minus 3, equals f of b. So in this case, remember, it's like a to b. So f of 2 minus f of negative 3 over 2 minus negative 3, right? And so remember, this is just an equation, right? So now we want to solve. So we first of all have to figure out what f of 2 is, and what f of negative 3 is. All right, so f of 2. All right, so 2 cubed minus 3 times 2 plus 5. All right, so 8 minus 6 plus 5, so 2 plus 5 is 7. So f of 2 is 7 minus f of negative 3. So f of negative 3 is negative 3 cubed minus 3 times negative 3 plus 5. All right, negative 3 cubed. Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. Minus 3 times 3, so that'd be plus 9 plus 5. Negative 27 plus 9 is negative 18. Negative 18 plus 5 is negative 13. All right, so 7 minus negative 13 equals 2 minus negative 3. 2 plus 3 is 5, right? So 3c squared minus 3, excuse me, all right, equals 7 minus negative 13 over 5. All right, so 3c squared minus 3 equals 7 plus 13 is 20 over 5, which is 4. So 3c squared minus 3 equals 4. So remember, the goal is to find c, right? So we have to solve this equation. So 3c squared equals 7. C squared equals 7 thirds. And c equals plus or minus the square root of 7 thirds. Now, let me make sure you understand. C must be a value in between negative 3 and 2. So then the question is are both plus or minus root 7 thirds answers? Or in other words, are plus or minus root 7 thirds both between negative 3 and 2? All right, so what is 7 thirds? Well, 7 thirds is 2 and 1/3, right? So we're taking the square root of 2 and 1/3. So think about it. The square root of 4 is 2. So the square root of 2 and 1/3 would be less than 2, right? So it's less than 2. And the negative would be greater than negative 2, of course. And so they are both answers. And so then plus or minus root 7 thirds would be both of the answers. Now remember, the mean value theorem guarantees that there is at least one answer. In this case, there were two, like that example I drew earlier. All right, but what if you solve for C here and you get both of these numbers are not between -3 and 2? Well, if that is the case, you made a mistake in your algebra or in your work somewhere, because the mean value theorem says there must be a number in between -3 and 2 where the derivative is equal to the slope of the secant. All right, so that is slides 9 and 10, and we will be doing 11 and 12 in class.